Alright, 1.5, we're going to be building graphs, building new functions from the graph. It's a pretty neat section, actually. It's one of my favorites. So we do these things called function operations, where you have to add, subtract, multiply, and divide function. And we're going to do that today, not divide. That's a long ways off. But we're going to use the graph to do that. It's really neat, actually. So we'll be building stuff. We've got some terms over here: zero product property, a polynomial, and a degree. Those are kind of important things. Sorry about that. All right, so let's look at the first problem. My book. Let me keep this in mind. Happens all the time. I have two books, one for the front of the room, one for the back of the room. Wherever I am, they are always both the other place. So one in the front or one in the back. And this in the front. Squirrel. Alright. So there was an earlier problem that we skipped, because that's what we did. We skipped stuff. And it was called You're So Square. You had to add functions to create a new function. So we're going to kind of do the same thing. Alright? So analyze the graphs of f of x and g of x. So look at those two graphs. What's happening with f of x? Increasing, right? F of x is increasing. It's going up. What about g of x? Decreasing. Okay, do you remember what kind of graphs they are? What are these called? They're five. Boom. Yes. Linear. These are linear graphs, okay? See, because it's a line, and that's a line. That means that they have a constant increase and a constant decrease. Constant means it doesn't change. So as they go up, they are constantly going up the same amount, and as it goes down, it's constantly going down the same amount. Okay, that's what makes it linear. All right, awesome. Okay, so now question A. Predict the function family of m of x if m of x equals f of x plus g of x. Explain your reasoning. Okay, so if I were to add these two functions together, whatever they are, I'm going to add them together. Is it still going to be in the linear family, or will it change over to something else? Let's talk about the function families. What all kinds of families of functions do we know? We obviously know linear. What else we got? Okay, but that's pretty, like, linear, nonlinear. Let me be more specific. That's like saying you are a Harper or you're not. List all the families at Manila, Harpers and not Harpers. So let's be more specific. I mean, it's right, you're a Harper or you're not a Harper. I don't know, this is Manila. It could be like, who knows. Anyway, all right, so there's linear. What's something else that we know about? What about this one? You remember what this one's called? It's U-shaped, yeah. What is it?
Parabola.
Yes, a parabola. It's called a quadratic. And it is U-shaped, and it is a parabola. Does anybody remember what makes it quadratic?
No, four quadrants.
No, 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 and no. This thing right here. X squared. Does anybody remember what one more is called? Like if I had one more power to that x? It's a cubic. It looks something like this. That's what it looks like. Okay. Like that. It's cube. One more would be quartic. And it's just a fatter U. Get a fatter U. No. Alright, and then like from there on we don't really name them. We say it's 5th degree, 6th degree, whatever. What about this? Does anybody know what this looks like? absolute value functions? What do those look like when you graph them? No. All lines are straight, first of all. Second, no, that would be linear. Absolute value, here's a hint. Value, it makes a V. Like that. We'll stop there for now. I don't think we're going to divide today, so we don't need to talk about any rational functions. Okay, so, going back to this, if I add this line with this line, will it still be in the same family? Will it still be a linear function, or is it going to be one of those others? What do you think? That turtle on that wheel. You turn it. Come on, let's go. You can think. What's it going to be? Alright, let's just try it. Let's just see what it is. Okay? We are going to add these two functions by their graph. Okay? Actually, look. You just forget the if I add 2x and 3x, what does that get me? 5x, right? Does the power of the x change at all? No, it does not. So if I add this line with this line, is the power of the x going to change? No. So this line plus this line is going to be what kind of function? Linear. Okay, it's going to be linear because we're not adding any power of x to it. We're not multiplying it. We're not getting it any greater power of x. Now, this one's going down. Let's see. This has a slope of -1. This one has a slope of 1/2. So if I were to add those together, it's more negative than it is positive. So I think it's still going to decrease. So if we're just predicting, if we're not actually adding, is it going to be as negative as this one is? Okay, so why? Oh man, why would you say that? I know why it's not as negative. I would say it's going to look something like that. If I were to add those two together, it would probably look something like that. It's still negative because there's more negative than there is positive. But it's not as negative as this one because I did add some positive to it, right? So it's not as negative. So that's my prediction of what that one would look like. What would be, anybody have an idea of a better, more accurate way to actually add these two functions together? I'm going to give you about 30 seconds to talk with your group. And you got to come up with yep.
Did you get to add the ordered pairs together?
Add the ordered pairs together? Okay. Write that down. Or maybe I'm not. There we go. Okay. Legions of Doom, what you got? Rise over run. And do what? Just put rise over run? Okay. Alright. Harper's minions.
Yeah. Formula's the order. Or not the order, not the formula's the,
No. complete. What you got?
Add the slopes.
Add the slopes. Alright, so we got 2 for that one. Alright. Miracle workers.
So we're not like on the X's. I'll put over to the
Find one of the x's. I'm going to put add them together because I don't have equations here. Alright, majestic unicorns.
You could find the equations of each line and you could add the slope and y-intercept.
Alright. Alright. Okay, I'm going to take part of 2 of these. Okay? I'm going to take this one. Yeah. And this one. Part of it. Except I don't want to add the ordered pairs, okay? We can add B right here. 4 and 1. I can add B right there. I can add the ordered pairs, except I don't need to add the X's. Those are inputs. When I need to add the outputs, I need to add the Y's. So pretty much, basically what you want to do is find some key points on your graph, like your y-intercept. That's always a key point. Where they meet is good if you can. Here's the thing. When it says key points, find points that are easy to see. Like I wouldn't go here, because you're going to, what is that? You're guessing. That's like, that one's like maybe a negative 0.6. No. Find points that are nice and lined up. This is a good one right here. That's a really good one. Your y-intercepts are good. These zeros are always good. That would be a good one. That would be a good one. Okay. Use those outputs. Which one's the output? The y. Use those outputs and add those together. Okay, the x's are the same. The x's need to be the same because that's where you're at the same point. Well, when I put negative 2 into this problem, I get 0. But when I put negative 2 into this problem, I get 6. So if I were to add these two together, this line is going to be passing through right here. When I put 0 into this problem, when I put 0 into f of x, I get 1. When I put 0 into f of x, I get 4. So this one's going to be passing through 5. When I put 2 into either one of them, I get 2, right? 2, because that's what I meet. And what's 2 plus 2? 4. So on this one, it meets right there. You really just need 2 points to make a line. It's easier with more than that because you can make sure you're doing really well. But that's what you do. And then you can just connect. And there is m of x right there. That's our m of x. So you just pick out some points and you add the output. You add them together. This is a very important statement right here. When sketching a graph of a function, you need to plot enough points to understand the general behavior of the new function. A line really just takes 2 points, okay? But what if it's a quadratic? What if your new graph is U-shaped? You're going to need more than 2 points. Because if I just have 2 points, look what I can do with 2 points. I can go this way, or I can go this way. So you're going to need some more points. If you know it's going to be a quadratic, you know it's going to be U-shaped, you're going to need more than 2 points. So when you're sketching a graph, make sure you're plotting enough points to get the general behavior. Okay? All right, let's look at problem 2. Keep on keeping on. All right, look at the graphs of J of X and H of X. Predict the family of functions. Hello. Predict the family of functions of C of X if C of X equals J of X plus H of X. Then sketch the graph. Describe the relationship between the original functions and C of X. Predict the family of functions if you were to subtract them, and then sketch that graph and describe that relationship. So I'm going to give you 4 minutes to do all of problem 2. Okay, 4 minutes. Okay, what family is that going to be in when you graph those?
Linear.
Linear. Yep, it's a line plus a line. Okay. So then you added them together and you sketched it, and what happened? Let's see. C of X ended up where? Just up, right? How much?
4.
Okay. What is it? 2 spaces away? The y-intercept is here at 2. So that's actually 3 spaces from where that one was.
I meant like it's on 2.
Oh, okay. What I meant was, and this is the hardest thing in the world to graph on, because you think your line is there and then it's not. So anyway, okay. So then you had to subtract it, and when you subtracted it, what'd you get? What's the y-intercept on the one that you subtracted? Did you get that far?
4.
What is it? It's not 4, it's... Yeah, -4, right. You got it, okay. And, it's still going to be parallel. Like that. Let me ask you a serious question here. Why are these all 3 parallel? Why didn't it change the slope? I'm just guessing. But I'm glad you spoke up, because these people didn't talk at all for the first 10 minutes. Okay, you started to say something, Easy Money. What?
There's no, I was gonna say there's no Y between X.
Okay, right here. Alright, there's a Y, but there is not. What is this one? What's the slope of this line? 0, right? So if I'm adding a 0 slope to this slope, is it going to change anything? No, it's not. It's going to be exactly the same. So that's why they are parallel, because this one has no slope. You're adding no slope to it. You're only shifting it up or down. That's it. Okay, good. Good. Okay. Great. So let's what? Hey, have you been here all the time? Okay, I'll have to change that because I counted you absent. All right. Look over to page 68. Am I there yet? Am I there yet? Now what do we have here? Yes, we have a parabola and a line. So, have this parabola and this linear function. What function family is it going to be in when I add these two together?
Cubic.
If I'm adding them, it's going to be a cubic. No? Okay.
Thought you. I thought they weren't the same.
Quadratic again? Okay, one. If I add them together, it's going to be a quadratic again. If I add them together, think about what makes it a quadratic, the x squared. So if you think about what makes the function, am I changing, by adding these together, am I changing the power of that x squared at all? No, because does adding change powers? No, it doesn't. Adding makes things bigger or smaller, move them around, whatever, but it's not going to change the power of anything. So it's going to be a quadratic. We just don't know what kind of quadratic it's going to be. We don't know what it's going to look like. So, pick some key points, okay? I'm going to give you like 1 minute to add these up. Pick key points. Remember, what are the key points? Yeah, easy, right on the line. Okay, like that's a good one right there. These are good. That one's probably good. They need to be right on the line to be key points, okay? So pick some key points and before all that. There's the answer. Okay. All right, on the next page, see number 6. Here, let me show you. There we go. Number 6 on the next page. I want you to do number 6, A, B, and C for homework, okay? For homework. We tore out 1-5 today. We're not going to get to 1-5, which I knew that when we started. A, B, and C for homework.